Yes, we start our third hour of this conference during the International Day of Clean Energy. We start this session with Dr. Simon Lucas. He leads the team for UK work on energy and climate in MENA region. Dr. Simon, it's our pleasure to have you among these great speakers during this conference. You can start your presentation.
Great. Well, first of all, thank you very much for the invitation to speak today. I've been very impressed by the range and knowledge of the presenters so far, and I hope to be able to add. I should introduce myself as I used to be an engineer, I should say, and in my early career, I worked a lot on wind power, solar power, and my PhD is in hydropower. So I share sometimes the frustration engineers face when the policies aren't right. And since I've moved from engineering, I've moved much more into policy work. So I also know the frustrations of keeping policies moving. So that's what I want to talk about today. I hope you can see the first slide of the presentation.
Yes. Yeah, we can see it. It's number 2 slides, I think, this one, yeah.
Great. Okay. So as I say, what I would like to discuss today, if I can get it to move. Right. Sorry, I'm having problems moving the presentation along.
You can use the arrows. What do you call it? What do you call it? The bottom direction arrow.
Yeah, here we go. Yeah, perfect. Okay, sorry about that. So what I'd like to talk about today is briefly why this is so important. I think that's been well covered, so I won't spend too long on that. A little bit around where the priorities need to be in terms of moving forwards, and really spend most of the time talking about UK experience, because I think that's probably the most valuable thing that I can share. So to start off, I think we've had plenty of discussion already and highlighted the need for action on climate. MENA is uniquely vulnerable for a whole set of reasons. It was already climate vulnerable before climate change started, and climate change is exacerbating water stress. Agricultural production is decreasing across the region, making it more dependent on imports in a competitive world. Saltwater intrusion is increasing, and we've heard already the big impacts on coastal cities of sea level rise. And we know that's important for the region to tackle. We know that the region is responding. We know that there is, some of the world's best solar resources in the region. We know that there have been lots of high-level commitments to move and accelerate the pace of the transition to renewables. It's been really impressive progress in the Gulf around, really getting hydrogen moving at a scale which is significant enough to make an impact on global emissions, and also give the signals to the world that if they move to use of hydrogen, then there's going to be production available. And that's really important about the signals. So it's important that that continues at the highest level. And I think that COP28, if you wanted a menu of actions for the energy transition, what actually came out was really important, because I think it was the first time that some of these issues have been addressed head on. They were contentious, but the outcome was really important, because the agreement that everybody needs to transition away from fossil fuels in an equitable and sensible and practical way is really important. The emphasis on tripling renewables capacity, tripling nuclear, particularly for baseload, improving energy efficiency, the cheapest and most effective way of solving energy problems, and often the most missed, working on reduction of methane emissions, and the phase out of fuel subsidies, fossil fuel subsidies, which has been already flagged previously, all that resource is currently being directed in the wrong direction. And it's really important that we work together to show that if the investments in renewables are going to be achieved, then we have to stop subsidizing other areas, because that innately undermines the market. But we can see that there's big investments going on. People have already talked about the big investments. We can see that the pace of deployment is accelerating extremely quickly from quite a low base, but it's really, really ramping up now. One of the things with the region that people underestimate is most of the economies are already based on energy. Okay, a different form of energy, but that provides a really good technical base for action. And I'm sure many of you are working in those sectors right now. But those core technical skills are going to be really, really important. Otherwise, deployment will lag behind and people's confidence will lag behind. Capital is available. I know there's a big debate about whether to invest in renewables versus new oil and gas. We have the same debate in the UK, and there's compromises to be made. But it's really important that over time, we accelerate the transition to renewables investment as opposed to oil and gas investment, because there's only so much money available. And I think most countries in the region agree that they need to diversify. The transition is going to happen. It's only the pace that's in question. Therefore, how can oil and gas dependent countries change their economies to remain energy economies, but a different form of energy? And as I mentioned, we also need to look at the social contract that exists in many countries, where oil and gas and energy derived from it provides a cheap source of energy to the population, but that money needs to be reallocated and costs need to be recovered, because renewables will, by their definition, need to pay their way. And if you're subsidizing a different energy source, it will inherently disadvantage renewables and deters investors. So there's a whole range of things that need to be looked at. And I know in Kuwait, you're aware of all these issues that are standing in the way, and have already put in a good lot of work to improve the market access and think about how to regulate. But I think that's the message. The most important message is, if you want investment, then you need to have that stable market access, and from the public side, be clear on what your policies are, what your grid access policies are, what your purchasing power agreements are, and what your exits for investors look like. And that's certainly a big part of the UK experience. So in the UK, I'm sure some of you will be aware, we have a Climate Change Act dating back to 2008 that really showed the advantages of the green energy transition. They've helped us reduce our emissions from the baseline of 1990 by 48%, whilst the economy has grown. So yes, there are trade-offs, but yes, it is possible to still have growth. And the part of our job is to demonstrate to economists that the technologies have changed, and that fossil fuel-based growth isn't necessarily more efficient or more effective or more sustainable in the long term than renewable energy-based growth. And the other indicator, if I'm honest, the UK was phasing out coal anyway, but it really accelerated the phase out of coal to the point where it's largely irrelevant to the UK's power strategy. More ambitiously looking forwards, 50 gigawatts of offshore wind by 2030, a big chunk of nuclear for baseload, leveraging private investment by, that should be 2030, 100 billion, and creating 500,000 jobs. And that's really important, because part of our strategy is to ensure that the more emitting sectors don't get penalised, and there are viable jobs for the economy. And that's really critical for politicians to be able to demonstrate that we are not going to be costing people's jobs by moving in this direction. A lot of work going on energy efficiency, electric vehicles, domestic heating, and the CBAM was covered earlier, we're no longer part of the EU, but we'll be introducing very similar regulations so that there's unity for the UK with the European regulations. And as I mentioned, ensuring that the private sector are part of all of those discussions, because making green investment boring is the goal. I learned this from a pension investor, and if you're a pension investor, they control vast sums of money in the UK and elsewhere, but they have to guarantee returns, and therefore they don't want surprises. They're happier with a slightly lower return as long as they know that the investment is as far as can be guaranteed. So how do you make that policy environment as boring and stable and predictable as possible? So what lessons have we learned? I would say that the UK has probably done most of the things it can do on the low-hanging fruit area. So, as I say, moving out of coal generation, improving efficiency and emissions from big production sectors like steel, chemicals, oil and gas. Those we've done the 80-20 rule of getting those emissions down. The areas we're focusing now is a lot around domestic heating, vehicles, energy efficiency more generally, but they require a much more different and nuanced approach, because you're talking about behavior change of individuals as opposed to big lumpy investments where you can demonstrate a good business case. I think we're also having the challenge. Heat pumps is a good example in the UK for domestic heating. Or air conditionings. If you're in the Gulf, it's the same machine running one way or the other. But there's been a lot of criticism of the early models, which have undermined credibility. The same with early electric vehicles. Unless there's charging points, unless the range increases, unless the cost comes down, they're not competitive. So as technology increases, the economics and the social acceptance changes. But there's a big perception problem now that needs to be overcome, say, on heat pumps in the UK. As with almost every other country, planning and project approvals become more and more tricky. The UK claims it's quite overcrowded. People like the English countryside the way it is, so getting approvals for wind farms is difficult, lots of local opposition. That's part of the reason why we've gone more offshore, but even the connection to the grid for offshore wind becomes a contentious local issue. So our planning regulations are now being updated so that we can increase the speed of connections. But the grid isn't ready, and we've had various presentations on the need to upgrade the grid. The investments are large, big discussion about who should bear the cost of that and how to spread the cost over a longer time period to enable it to go ahead. Lots of discussion, and I'm glad others picked it up, around how do we integrate grids more. There's lots of analysis around that show that integrating grids, because of variable loads in different geographies, can really improve the utilization efficiency of renewables and match demand with supply much more efficiently. So whether you're part of the one sun, one world, it's always sunny somewhere in the world, so why not supply a global grid? If that's the end goal, how can we start increasing those interconnections? And I know there's lots of discussions going on in the MENA region, but also between MENA and Europe, and we'll be part of those discussions. Of course, last year, with the war in Ukraine, energy price shocks was a #1 issue for politicians in the UK. And that's undermined a bit of the confidence in the energy transition. But we have to keep demonstrating why it's still a good long-term goal, and investing in transitions so that the losers or perceived losers are well looked after. Otherwise, the political momentum gets lost. And this is taken from a UK website from last week. We are looking at reducing the number of coal-fired blast furnaces in South Wales, 3,000 jobs being lost. How do we compensate and how do we replace those jobs? and that's a real key issue for people. And we're coming into an election year, so all these things are common to many other countries. We've got lots of experience that we'd like to share with you on that, whether that's on collaborations on oil and gas, methane, improving efficiency of production, policy reforms around how to design just energy transitions, on subsidies, on the work that we're doing in the North Sea fields on transitions, technology partnerships. There's already a lot of work going on hydrogen production, carbon capture, utilization, storage, flaring, etc. We deregulated our energy system quite a long time ago, so there's a lot of lessons, good and bad, I would say, on energy sector regulation and how to incentivize investments in the capacity market to provide power when the wind isn't blowing, for example, is a really good example of how do you solve that with a private sector investment when utilization is low. So how do we actually go about modeling that and setting the price right so that we're not overpaying for capacity on the grid, storage capacity on the grid or nuclear, but we've still got stability of supply. So lots of opportunities for government-to-government collaboration, business to business, and research and development. So I hope that was useful. I'm more than happy to take questions at the end if there's anything about UK experience or opportunities for collaboration. But once again, thank you very much for giving me the opportunity to talk today, and I'll hand back. Thank you.
Thank you. It was really great, Dr. Simon, to show some lessons and some challenges. I think it's very good to take it in considerations for other countries and other methods to know how to what are going to face in the future if you take this path or other path. It's very great, Dr. Simon, and now we'll move to our next speaker, which is who's Mr. Joel Gold. He is a senior manager at B0 Carbon Company. Mr. Joel? Hi. I think the mic is not, we are not hearing it. You are not muted, but the sound is not reaching. You may go to the mic and select the arrow next to the mic, and you can select the same as the system, speakers and so on. Select the speaker, select the microphone, yeah. Same as the system. Yes. It came and then went off. Mr. Joel, would you like to move to Mr. Abdul Karim and then we'll go back to you? Yeah, that's great. Now we'll go to our speaker, Mr. Abdul Karim Abdul Razak, until Mr. Joel, maybe he will be the last one. Mr. Abdul Karim, he is a scientific researcher at the University of Oldenburg. Mr. Abdul Karim, you can start your presentation.
Yes, you can hear me well?
Yes, yeah.
So I'll share my screen. Looks fine.
Yes.
And it's moving. Okay.
Yeah.
First of all, thank you, Engineer Salim, for this invitation and to be a presenter in this wonderful night. With this all interesting topics, with all very exciting topics we heard today. Good evening, everyone. I know I'm from the last presentations. You're probably tired, but I hope that my topic will energize you again. So we explore. So I will explore the stages of wind project development. Wait a second, just a second. Yeah. Okay. The stages of wind project development from site selection to decommissioning, and then I will discuss the challenges and opportunities of wind turbine recycling. So buckle up and get ready.
Yeah, this.
So you can hear me well? Is it a problem?
No, it's fine.
Okay, so my name is Abdulkarim Abdurazek again. I will guide you through this journey into wind turbine recycling. I'm a passionate researcher in the field of wind energy, currently doing my PhD at the University of Oldenburg, and also I'm an accredited trainer at SRH from the SRH Berlin University of Applied Sciences, and I serve as Managing Director of Solar Power Services. Solar Power Services is a consulting firm specialized in renewable energy solutions, particularly in wind and solar power. We offer comprehensive design services from initial concept to final implementation. We also supply meteorological stations for wind and solar for an efficient planning and operation of wind farms and solar farms. Additionally, we conduct training programs to raise awareness and expertise in the renewable energy sector. So let's start with the wind development stages, wind project stages. So as a first stage, we begin with the selection of a site. This involves assessing the wind source at the potential site, considering factors such as wind speed and direction, turbulence intensity, and land availability, grid availability as well. And then we do a feasibility study to evaluate the economical viability of the project, including costs, revenues, and also we look at potential impacts on the surrounding environment. After that, we look at or we try to obtain the necessary permits and approvals from the government, which then we can go to the next stage, which is securing the finance by contacting investors or banks and provide them with the necessary documents and bankable reports. And this is the bankable report is of course based on our 1 to 2 years of measurement, site measurements. So then after we secure the financing, we go into the construction. After the construction phase, which is about half a year, we can start doing the testing and commissioning. This involves checking all electrical and mechanical systems, ensuring proper functionality of all wind turbine components. And after that, we come to the operation and maintenance, which is very important phase, where we do irregular inspections and do necessary repairs to ensure continued optimal performance and safety of the wind farm. And after 20 to 25 years of operation, we come to the last phase, which is called decommissioning, which in this case, we reach the end of the operational lifespan of wind turbines. And in this, we need to dismantle the turbines, separate the various components and process them for reuse or disposal. And this is where the rest of the slides will be focused on this topic, recycling. So wind energy is rapidly becoming a cornerstone of the global energy transition, so offering a clean and renewable source of power. However, as the lifespan of the wind turbines draws to a close, the question of how to responsibly recycle these large and complex structures becomes increasingly critical. So we need to deal with this composed of these several major components of the wind turbines. Luckily, we have 85 to 90% of the wind turbine components or total masses can be recycled, and have established recycling practices in place already. But still, there's some challenges, especially for the rotor blade. As you see in the figure, this is the rotor blade. And it's the most challengeable component to recycle due to their composite materials. So it's consisted of fiberglass, carbon fiber, and resin. So this is make it difficult to recycle. Let us look at this picture to see how crucial is the problem. So you need a large landscape to dispose of all these plates. And there's a lot of plates now, 10,000s or 10 of thousands of plates are, their life is reaching, so their life is coming to end. So we need to put them somewhere. So there's some people are trying to bury them underground, like in this picture, as you see here. But the question is, is it a good solution to do this, or we look for another solutions? I will answer this question in a few slides. But first, let's continue the components of the wind turbines. We have the nacelle, which is the house which houses the turbines, generator equipment, typically made of steel, copper, and aluminum. So it should be not a big deal of recycling. Then we have the tower itself that supports the wind turbine. That supports the turbine. And then you have the foundation, which anchors the turbine to the ground. And it's also made of concrete or steel or both of them. And it's also not a big problem to recycle. So let's sum up. Recycling of most wind turbine components is relatively straightforward, like for steel, copper, and aluminum is not a big deal. However, where locates the problem is the blades of the turbines. So we have three main types of recycling they're tackling to solve this problem, which is the mechanical recycling. It's easily, you shred the plates into smaller pieces that can be further processed for recovery of fibers or resins. Then comes the second type is the thermal recycling that involves heating the plates to very high temperature, which breaks down the resins and fibers into components. Then you can separate them and produce new materials from them. And the last one is the chemical, also the same concept as heating, but using here chemicals. You break down the resin bonds in the composite material, enabling the recovery of individual fibers. So we now recycle the plates. What we can do with this material? So the recovered materials from turbines can be used in various applications. Like, for example, if you recycle the plates itself, you can use them as asphalt reinforcement, building materials, or even new composite products. Recycled metals is more easier to process. You can use them to produce new wind turbines, but in the case of plates, it's not that easy. You need to ensure that the plates has really certain strengths that can hold the forces from the wind itself. So I guess recycling is not a good option in this case. So we have plenty of plates available in the whole world. So if we cannot recycle them and we cannot bury them, what we can do is other innovative solutions, like, for example, use them as bike parking stations. And it comes to me in mind yet now that we can install on this top of these plates solar panels, and we can charge e-bikes, for example. So we have both. Two-in-one option. Also, we can use them as a kids' playground, as you see in the picture here. This is a picture in Netherlands. Yeah. And we can, if you don't want to do all of these, and this is my favorite solution to this problem, is to go to solve the problem from its source. So what you need to do is produce wind plates that are recyclable. So companies are developing nowadays innovative technologies and processes that have the potential to make wind turbine recycling a more viable and cost-effective option. So in my opinion, we need to have both solutions. You need to have recyclable plates that in the coming future turbines that will have in 20 years will not have a problem because they are already easy to recycle. And second, the process that eases the recycling of the already existing turbine blades and make it as cost effective as possible. So there's some companies working on that, like Vestas. It's a well-known manufacturer of wind turbines. It's a Danish company, has committed to make all their turbines up to by 2040 with recyclable blades. Also, Siemens Gamesa has developed a blade design that uses Siemens Gamesa is also it's a Spanish-German company that also manufactures wind turbines. They developed a blade design that uses a less resin-intensive composite material. And there's the other approach, which you develop a process to ease the recycling process, like the company Equinor. It's a Norwegian company, has also developed a process to recover the fibers from wind turbine plates and use them to produce new concrete products. So all this efforts, I guess, will make the wind turbine or wind future more sustainable. So let's sum or conclude all these ideas. Wind turbine recycling is essentially to ensure that the sustainability of wind energy is a major source of renewable power. With ongoing advancements in recycling technologies and industry commitments, we can confidently move toward a future where wind turbines are not just a source of clean energy, but also contributes to a circular economy, thus creating new business models and more jobs. And hopefully that so our MENA region or Arab world is part or contribute to this part of businesses. And thank you so much, and ready for your questions. I hope I'm on time or maybe less.
Yes, you are on time, Mr. Abdul Karim. Thank you for this presentations. Actually, you raise very important issues, which is the end of life of renewable energy products, such as wind turbines and also the solar PV modules. We feel we are feeling the problem now, but it's going to be a big problem in a few years, and I think we need to find the solutions for this kind of issue. Thank you, Mr. Abdul Karim.
Yes, exactly. Especially, exactly. Especially the plates are becoming larger and larger.
Yes. Yes. Thank you, Mr. Abdul Karim, and
you're welcome. Thanks a lot.
Now we'll move to our dear friend, Mr. Joel Gold. He is a senior manager at the B0 Carbon Company. I hope the mic now it's working. Yeah.
Hello, can you hear me now?
Yes, now it's great, Mr. Joel.
Fantastic. Thank you very much.
You can now share your presentations. You can go ahead.
Yes, I'll do that now. Great. I hope you can see the presentation.
Yes, we see the B0. Yeah.
Great. So thank you very much for inviting me to speak here today. I'm representing the company that I work for, B0 Carbon, which is a global carbon rating agency. So I'm going to speak to you today about the role of ratings in building high quality carbon markets, which B0 is right at the center of. So just starting with the kind of basic question, which is why carbon ratings are important. We as a company view investing in carbon projects as essential to tackling climate change. And we believe that in order for those markets to scale and for investment to go into those carbon projects, what's required is independent, risk-based, project-level carbon ratings, which provide the market with the information it needs to make to channel the investment capital to where it needs to go. And what ratings are aiming to do is to solve the kind of critical problems of integrity that exist in the market. In recent years, the carbon market and some carbon projects have come under some scrutiny in terms of what they're delivering. And what we're aiming to do is provide risk information to the market and give buyers and investors in the carbon market confidence to make net zero claims using carbon credits that are generated from carbon projects. So this just kind of summarizes what I just talked about there in a little bit more detail. So the objective being to scale carbon markets and to do that by making carbon assets as investable as traditional financial market asset classes. In order to do that, the market has to mature and have appropriate risk management tools as exists in financial markets. And that's all about providing information to the markets about risk to enable the price mechanism to work properly, to enable the price of different carbon assets to be priced in an appropriate way. The solution, as we see it, is to provide that information in an easily digestible format, which is a rating. So the primary market that the B0 currently operates in as a rating agency is the voluntary carbon market. And this slide just provides a brief overview of the voluntary carbon market and how it operates. So we have project developers that develop carbon projects around the world, whether they be renewable energy projects, nature-based projects like reforestation, cook stove projects, direct air capture, and other removals projects. And they obviously they need investment to start, and the way that investors, the incentive for investors to invest in these projects is that the projects generate a return, a revenue based on generating carbon credits, which are sold in a market. That might be on exchanges, marketplaces, or direct trades. The end buyers for these credits are often corporates who are seeking to offset their carbon emissions while they're on their route to net zero in their own operations. And the ultimate sort of destination for carbon credits is retirement. And retirement means that the credit is no longer available for purchase, no longer available for trading, and the organization that's purchased the credits has effectively used that to offset a portion of their own emissions. The voluntary carbon market is currently estimated to be worth around 2 billion per annum, and there are various estimates as to how large that market is going to become within the next few years through to 2030. There are a range of estimates through up to sort of 100 billion from some market analysts. But what's really critical if the market is to get to that stage is rebuilding buyer confidence in the projects underlying the market. and that's what B0 and other ratings agencies are aiming to do by providing the market with that risk-based information. Wanted to just add this slide in, given the context of this conference about the voluntary carbon market in the Middle East, which is a really important region, particularly on the demand side of the market. So there are some major exchanges for the voluntary carbon market that have been launched in recent years or are going to be launched in the Middle East region. Of course, the UAE hosted COP28, which where the voluntary carbon market was discussed and given credibility through various announcements by various countries. So yeah, the Middle East is a very critical region for the voluntary carbon market. So the ratings that B0 provides information and services all parts of the market. So from the origination point of the carbon market, project developers, helping them to kind of grow buyer confidence and find buyers for their credits, helping them to differentiate themselves from other projects. For investors, helping them to find the right projects to invest in, obviously through to end buyers and traders, in enabling them to make decisions about which credits they should purchase. So in terms of what the rating actually looks like that B0 provides, it is based on the principle that the carbon efficacy is not binary. Quality in the market is not binary. It's not a simple yes, this achieves 1 ton of carbon dioxide removed, or this doesn't. There are a range of carbon efficacies across projects, and this brings us to the B0 rating scale, which reflects that kind of probabilistic nature of as we see it, of carbon projects. And so what the B0 rating scale does is assign one of these ratings to projects, and it reflects the opinion of the company of the likelihood of a credit delivering a ton of carbon dioxide, either removed or avoided. And we've recently launched a new kind of parallel rating scale, which is an ex-ante rating scale, which is obviously exactly the same, but it's based on credits before they've been issued. So traditionally the company is focused on projects that have completed and have issued credits. The ex-ante rating scale is for pre-issuance projects. So focused on more that early stage of the market and providing project developers and investors with information about projects. How the ratings are actually produced. So they capture 3 main factors, which is additionality. So you know, would the projects have happened anyway in the absence of the carbon credits being generated? Carbon accounting. So you know, are there kind of leakage concerns in the project in terms of its ability to remove or avoid carbon being emitted? And then finally, non-permanence. Are there risks in kind of the project not being a permanent solution for avoidance or removal of carbon? And what kind of underlies those aspects that we consider is lots of geospatial data and information about projects. So we have lots of partnerships with various companies and organizations which provide geospatial data. That's really the key kind of underpinning data source that enables us to make those judgments about carbon efficacy. This slide just shows the range of projects that we cover and the ratings that were provided, that we assign to them. And kind of key point of this is that we assign a range of ratings to a range of types of projects. So it isn't the case that certain types of projects are kind of inherently better than others in their carbon efficacy. It really is you know, going down to a granular project detail level. And then just finally, just a couple of slides just about the kind of impact in terms of that kind of question that I posed around our ratings building efficient carbon markets. So you know, the company's ratings are being used and used by, you know, 5 of the top 10 investment banks, 5 of the top 10 energy and commodity firms, 5 of the top 10 carbon marketplaces, and 2 of the top 3 exchanges for the voluntary carbon market. So we're getting you know, strong reach into really key areas. And then finally, you know, that reach is leading to what we really want to see, which is the ratings that we're giving to carbon projects being reflected in the price of the credits that they're generating. So you can see on the left there the kind of basic correlation between the kind of average price for each rating level, and a pretty good correlation there. And then the graph on the right showing the price difference between our top rated credits versus our lower rated credits, and that price difference kind of growing over time. And you know, what we think that shows is the market really maturing, becoming more like that kind of efficient, akin to the financial markets, you know, piece that I set out at the start of the presentation. So we're hoping to see that continue and grow going forward. Thank you very much, and yeah, happy to take any questions.
Thank you, Mr. Doyle, for this interesting presentation. Actually, I believe that the carbon market is going to be a main playmaker for the success in the energy transitions in the near future. Thank you for this information about your, you know, the scope and the applications that you have, you kind of provided through your company, through your agency. Now I think actually now we reach the end of the speaker's presentation session. This is the end of that, and we will start soon. After that, with the discussion panel, the questions Q&A. Before we move to the Q&A, just some remarks and notes. For the audience, they ask about the certificate of attendance and the presentations. They can get it through communicating with the WhatsApp number that is shown in the post of the conference. So, and also there is a certificate for our dear speakers. We can provide it after in a few days. Now, before we start the Q&A, we stop this recording.